Okay, so number 2, it says a rectangular plot of land is to be fenced in using 2 kinds of fencing. 2 opposite sides will use heavy-duty fencing selling for $3 a foot, while the remaining 2 sides will use standard fencing costing $2 a foot. So if the area is to be fenced in is 150,000 square feet, find the dimensions of the rectangle that could be built with the cheapest cost. Okay, so I'm going to let one side be X and one side be Y. Okay, and X is going to be, let's say, $3 per square foot. And Y is going to be the $2 per square foot. Okay, so first I need to start out with the area is going to be 150,000 square feet. So I'm going to have X times Y equals 150,000. So these optimization problems will often start out with 2 variables, but you need them to be 1 variable in order to take the derivative. Okay, so I'm going to solve for Y, so I get Y is equal to 15,000, or not 15,000, 150,000 divided by X. Okay, so I want the cheapest cost, so I'm going to call it C. Okay, so the cost of the fencing is just length, so you're going to have the length times $3 for each of the X's. So I'm going to have 2x, and they're each going to be multiplied by $3 per square foot. Oh, actually, not square foot, it's a foot. Makes more sense. Okay, and then for the other one, I'm going to have 2 times y times $2. Okay, and like I said, we're going to replace the y, so I get 6x plus 4, and then y was 150,000 over x. Okay, so when I multiply 150,000 by 4, I get 600,000. So 6x plus 600,000, x to the negative 1. Okay, and this is what I'm going to minimize. Okay, so I'm going to do c prime equals 6, and then I'm going to have negative 600,000, and it would be x to the negative 2, so I'm going to do over x squared. And I want to set it equal to 0. So I'm going to add it over. Too many zeros. Okay, and I'm going to multiply the x squared over and divide by 6. So I get 100,000 is equal to x squared. So if I take the square root of 100,000, I get the square root of 100,000 is equal to, run out of room, let me move this up. $316.2277, so I'm going to say 228. And you can always store that in your calculator if you need it. All right, so that's going to be x, and you need to find y as well. So y ends up being, remember, x times y is equal to 150,000, so, 150,000, so divided by, so I get y is equal to 474.342. Okay, so if you need to find the cheapest cost of the fence, you just plug in. So you do your 316.228, you multiply by the 2 sides of the fence, and you multiply by the $3 per foot, and then the 474.342 times 2, and then times $2 for each one. So I'm going to see what that is. Okay, so I believe that is $3,794.73. And that should be the solution. Okay, number 3 says the number of flies around a dropped piece of bread is modeled by the function p of t equals 1,000 t over 10 plus t squared, where t is measured in hours. How long will it take for the number of flies to be at a maximum? So hopefully you guys figure this one out. So you're just going to do p prime. You can need to do the quotient rule. So the quotient rule, remember we use low d high minus high d low. So it's going to be low d high minus high d low, so it ends up just being 2t, all over the square of what's below. Okay, then we set this equal to 0. Now when we're finding critical values, we need to find when the numerator is equal to 0 and the denominator is equal to 0. Okay, so a lot of times with the quotient rule, we'll have a trick where we have a common factor. So in this case, we have 1,000 that we can pull out from both of them. So I'm going to have 1,000. Then I'm going to have my 10 plus t squared minus 2t squared. And then over 10 plus t squared squared. Okay, so the 1,000 doesn't really matter. It's really the 10 minus t squared that we're worried about, equaling 0. And then on the bottom we have 10 plus t squared. That could also equal 0, but it really doesn't give us a solution, a real solution. So that one's out. So it's really just t equals plus or minus the square root of 10 when we solve that first one. Okay, so we're going to put both of those on a number line. And it is a time, so really we shouldn't have anything less than 0, right? So I'm going to start at 0, and then I'm going to put the square root of 10 on the number line. So I don't really need the negative square root of 10. All right, I'm going to test on the left and the right. So square root of 10 is around 3 point something. So if I try 1 in the derivative, I get 1,000 times 10 plus 1 minus 2 over 10 plus 1 squared, so 11 squared. So I get 11 minus 2, 9. It's a positive number, right? So if I try 4, I get 1,000 times 10, and then I'm going to have minus t squared, so it's going to be minus 4 squared, so minus 16. So that's giving me a negative number, and the bottom's always going to be positive, so it's negative. So that means it goes up and then down. So since p prime is increasing and then decreasing, that means p has a, well, not p prime is increasing and decreasing, p is increasing and decreasing. P has a maximum at square root of 10. So how long will it take for the number of flies to be at a maximum? Square root of 10 hours. So if you wanted to write that as a decimal, the square root of 10 is 3.162 hours. And that's your answer.